Okay, for example 4, it says find the least common multiple of x cubed minus 9x, x squared minus 2x minus 15, and x squared minus 5x. So this time we have three pieces, three objects. So expression 1 is x cubed minus 9x. Expression 2, x squared minus 2x minus 15. Expression 3 is x squared minus 5x. So again, our first task in finding the least common multiple is to factor each and every expression completely to the most we possibly can. So if I start with x cubed minus 9x, first off, x times x squared minus 9. Always look for a common factor first. If there is one, take it out. So x is a common factor, so I wrote the common factor x down. And I divide everything by x, that makes x squared minus 9. Some of you are not writing the greatest common factor down, you're just dividing by x. You're just saying divided by x. And don't write it down, okay? We're trying to create the exact same expression just in factored form. So we need something times something makes that. What was common was x, it gets written down. What was left over is x squared minus 9, it gets written down. The product of these things is equivalent to this. Both pieces are necessary to be part of the factored form. All right? Then x squared minus 9 is our difference of two squares. Again, there's no, it's a recognition thing. X squared minus 9 is x plus 3 times x minus 3, because that's how you factor x squared minus 9. There's no technique to it, it's a recognition of structure, and then you take some square roots. X times x is x squared, 3 times 3 is 9, make one a sum, one a difference. So x times x plus 3 times x minus 3, all to the first power, is the factored form of x cubed minus 9x. And I do recommend you putting the out powers on there because, again, one of the processes, one of the steps in the process is to identify the highest power, so seeing powers is helpful. The second expression, x squared minus 2x minus 15, that's just your basic quadratic trinomial, 1 in front of the x squared. So we're simply looking for two numbers that multiply to make negative 15, and also add to make negative 2. Negative 5 times positive 3 is negative 15. Negative 5 plus 3 is negative 2. So negative 5 and positive 3 are the magic numbers. So x minus 5 times x plus 3 is the factored form of x squared minus 2x minus 15. Again, there's no powers listed, so that's officially the first power and the first power. My final expression is x squared minus 5x. X squared minus 5x, common factor is x. I'm going to write down my common factor of x. And what's left over when I divide by x is going to be x minus 5. X is the first power, x minus 5 is the first power. Everything's the first power here. So when I go searching for the highest power in this third step, they're all going to be first powers, right? So step 1 is factor everything. So I'm looking now at this expression, fill the box here. This is what matters to me in this point, once I've factored everything completely. My second step is to write LCM equals, and then I write down everything that happens as a factor, individual factors that are in this box. Okay? I don't care if they happen 1 time or 55 times. If they happen once, they get written down once. If they happen 10 times, they get written down once. So what I see is x plus 3, x minus 3, and x minus 5. And again, if I just do a quick inventory over here, there's x happening, there's x plus 3 happening, there's x minus 3 happening, and here's x minus 5 happening. Whether they happen 1 time or multiple times, you write them down 1 time each, right? Wrote down x, wrote down x plus 3, x minus 3, and x minus 5. The highest power of each of these factors is 1, right? Because everything's the first power here. So just a bunch of 1s, I'm not going to write the 1s. Okay, now, because again, this is going to happen almost every single time you do these problems, I'm going to try and make sense of this to everybody, make sure we all get this, because I want you to save time and energy when possible. This expression came from here. This equals this, this equals this. They're the same thing, right? This is right here. So if x cubed minus 9x breaks down to x times x plus 3 times x minus 3, and now I've got x times x plus 3 times x minus 3, I have to put it all back together, that's just going to be x cubed minus 9x. No FOIL necessary, no polynomial multiplication necessary. This broke down to this, and now I'm trying to go back, so I'm just kind of shortcutting it here. That's still being multiplied by x minus 5. Nothing over here says what that product is, right? Nothing over here says x cubed minus 9x times x minus 5 equals something up here, right? So now I've got to do some polynomial multiplication here. This is a binomial structure being multiplied by a binomial structure, so just a little FOIL is going to work. X cubed times x makes x to the 4th. X cubed times negative 5 makes negative 5x cubed. Negative 9x times x makes negative 9x squared. And negative 9x times negative 5 makes positive 45x. There are no like terms in that expression, so that is the simplified final answer for the least common multiple of this expression. So, that's the technique of least common multiple. Factor everything completely, write down every factor that happens, take the highest power of each one, and then multiply it back out. And again, look for a piece that's in here that's already been factored from an original piece, and you just go ahead and take that entire thing and put it back together. Or you can go ahead and FOIL everything and distribute your property everything and have a whole bunch of work on your paper, that's fine. But when you can save a little time and energy like that, that's fine with me. If you recognize that, it shows an understanding of the problem, so I don't have a problem with that.